Hello everyone, I'm Yogita Shirke. Today I will talk about the impact of stretching condition on the microstructure and filtration efficiency of the EPTM membrane. So membrane has a different application and there were different kind of membrane have been used like organic, inorganic, composite material. So among these the PTFE is the very good polymer which is used for chemical stability, hydrophilic, low surface energy, and it has a very good ductile properties. That's why it is used in different kind of the application. So basically we'll talk about what is PTFE and EPTFE membrane. So PTFE is kind of the polytetrafluoroethylene, and ePTFE is a microporous air permeable expanded PTFE material, and it also used in different applications. So here we use the lab scale using specialized stretching equipment with the real-time monitoring system, and we change the different type of the stretching parameter to get the uniform thickness and the micropore size of the material to use it in a different kind of application. Here you can see we put the PTFE sample inside the chamber, and with the different kind of parameter it getting stretched, and we get the uniform thickness and stretching or stretched membrane. So we use the different parameter like the stretching ratio, and we change the stretching ratio from the 400 to 1000 percentage, and with the different stretching parameter, the fibril length and my mean pore size of the material getting increased, thickness also increased, permeability also getting increased. Also we check the stretching speed like SS for check the stretching parameter. So we change the 10 to 150 mm per second as a stretching speed parameter, and we conclude that the stretching speed has a notably greatly influence on the quality of the PTFE membrane. And also we check the stretching temperature effect to get the check the properties of the stretch EPT membrane. Also we check the different annealing time like 0 to 60 seconds. Here we used NaCl as aerosol particle, and we used the ePTFE membrane to check the filtration performance of the membrane. And here we found that the MD stretching speed influences the greater parameter on the efficiency of the membrane. With increasing the stretching speed, the performance of the membrane like filtration efficiency and quality factor getting increased. We have been checked with the different literature study, and we found that the EPTFE 50 membrane gives the highest filtration efficiencies around 99.30% and 0.0326 Pascal quality factor. And we can say that this stretch EPTFE membrane not only used for the filtration application, we can also use with the different application like functional clothing, or we can use this membrane in the proton exchange membrane, like we use as a RCM membrane to impregnate the ionomer. So it has a very different industrial application. So in summary, we will say the effect of the parameter in EPTFE membrane stretching we systematically investigated like stretching ratio, stretching speed, stretching temperature, and handling time. And stretching speed has a greatly influence and effect on the morphology, thickness, and of the EPTF membrane. And among these, the stretching speed with the 50, it gives a good quality factor, high filtration length, and the compliance pressure drop. Thank you.